Welcome, my dear students. Today our topic is heat. In the heat chapter, today I would like to explain the fill in the blanks and multiple choice questions in detail. The first bit is the SI unit of specific heat is. The SI unit of specific heat is joule per joules per kg and Kelvin. Kelvin. And dash flows from a body at higher temperature to a body at lower temperature. Generally, the heat energy is transferred from the hot body to the cold body. That's why the answer is heat energy. Heat energy is transferring. For example, if you take a hot bowl, on that bowl, suppose if you keep a lid, after some time if you observe whatever the hot ball that is lost some energy, and also the lid gains that energy. Like that, the heat energy is flows from a hot body to the higher temperature to the lower temperature. Dash is a cooling process. Evaporation is a cooling process. Evaporation is a cooling process. An object A at 10 degrees centigrade and another object B at 10 degrees Kelvin are kept in contact, then heat will flow from which body to which body. So here the readings are given in a different scales. That means for object A is in degrees centigrade and object B is at degrees Kelvin. That means Kelvin. Okay, so that's why we have to be convert that one we have to convert that one into the degree centigrade. That's why the formula is C equals to minus 273. So what is the Kelvin given for us? 10 minus 273. That implies B is minus 263 degrees centigrade. A is 10 degrees centigrade and B is minus 273 degrees. That's why the heat will flow from hot body. That means hot body here is A and the cold body is B. That means A to B. The latent heat of fusion of ice is, the value is 80 calorie per gram. 80 calorie per gram. Temperature of your body is directly proportional to the average kinetic energy. That means if the average kinetic energy is increases, the temperature of the body is also increases. That means temperature of your body is directly proportional to the average kinetic energy of the molecules or atoms. According to the principle of method of mixtures, the net heat lost by the hot body is equals to the heat gained by the cold bodies. That means, so previously I told you, suppose if we take a hot ball, on that hot ball, suppose if we keep any lid, automatically the amount of energy is losing by the hot body. That whatever the energy it is losing, the same energy is gaining by that cold body. That's why heat gain. The sultriness in summer days is due to humidity. The sultriness, we are feeling that sultriness because of the humidity. Okay, dash is used as coolant. For example, if the radiators are heating, automatically we are using one coolant. That coolant is a water. Why? Because the specific heat of the water is more. That's why water is used as a coolant. Ice floats on water because, why? Because ice has less density. Ice has less density. That's why we are observing the icebergs. In the icebergs, they are floating on the water. Which of the following is a warming process? So evaporation, condensation and boiling and all the above. Well, here the condensation is a boiling process. That's way B. Melting is a process in which solid phase changes to melting. That means in this state the material is changes from the liquid phase to the solid state to the liquid phase. But here we should be remember that is at constant temperature. That's why the option B is correct. And three bodies, that means A, B, C, are in thermal equilibrium. That means they are in same temperature. They are at the same temperature. The temperature of B is 45 degrees. Suppose B is 45 degrees, automatically C is also 45 degrees centigrade. That's why third bit option A is correct. and the temperature of a steel rod is 330 Kelvin. Its temperature in degrees centigrade is. So here also we have to use the C equals to K minus 273. That equals to K, how much given? 330. 330 minus 273, that equals to 57 degrees centigrade. 57 degrees centigrade. That means the option B is a correct option. And kerosene oil, iron, copper and water. Out of 4, which has a more specific heat? So out of 4, as I already told you, water is having a high specific value. Water is having a high specific value. Specific heat, S equals to, the formula is Q by delta T. Q is the heat energy and also T is the change in temperature. The option is A correct. Boiling point of water at normal atmospheric pressure. Boiling point, it is we are taking as a upper fixed point while we are calibrating the thermometer. That's way 100 degrees centigrade is a boil point. Boiling point of water, and the option B is correct. And when ice melts, its temperature. When ice melts, that means it is become converting like a water, but at the its temperature definitely it should be a remains constant. That means at 0 degrees only. Okay, only the state is changes, not the temperature is changes. That's way the option A is correct. These are the important bits given in our test book. There are few more bits I would like to explain you, my dear students. So you should be read them for your competitive examinations purpose or the short answer questions. Okay, hot and cold are relative terms. Hot and cold are relative terms. What is relative terms? Relative terms means, for example, if you take 3 bowls, one bowl with hot water and another bowl with lukewarm water and another one with cold water. Suppose if you immerse your finger in the hot water, after that if you put it in the second bowl, you may just feel that a little bit of coldness. But suppose if you take same finger in the lukewarm water and if you put it that one in the another finger, that means cold water, you may feel hotness. That means like this, hot and cold is also relative. Okay, based on the comparison those are changing. When heat energy enters our body, we get a feeling of how we can feel heat energy. Suppose if we are touching any hot body, how we can feel? We can feel a hotness. Why? Because the energy is transferring from the hot body to the cold body. Our human body temperature is 37 degrees centigrade. Okay, temperature is a measure of degree of hotness or coldness of your body. Degree of hotness or coldness of a body. It is at thermal equilibrium. That is also a measure of a thermal equilibrium, hotness or coldness of a body. And the SI unit of heat is joule. Actually, joule is the scientist name. While we are writing the scientist name as a unit, if you are writing that one as a full, you should be use the first letter should be small letter. As a symbol, if you are writing that one as a capital letter, you should be used. And CGS unit of heat is calorie. CGS unit, and generally that is denoting with cal. 1 calorie which is equals to the 4.186 joules. Temperature measured on Kelvin scale is called as absolute temperature. The total internal energy of this system is called as internal energy. What is that? Internal energy. That is kinetic energy, vibrational energy. So all those energies we are calling as a internal energy of the system. Evaporation is which phenomena is? That is surface phenomena. That means only the upper layers are evaporate. And evaporation is also a surface phenomena, and it is a cooling process. Suppose if the atoms or the molecules are evaporating, means automatically whatever the inside layers are, they are becoming cool. Okay. Condensation is a warming process. Condensation means suppose we are getting rains because of the clouds. That means the clouds are absorbing the water from the oceans, and also after that they are converted into a water rain. Like that process is called as condensation. The amount of water vapor in air is called as, this is called as humidity. Because of this one, we are feeling in the summer sultriness. Heat energy utilized to change the state of liquid to vapor is called latent heat of vaporization. Latent heat of vaporization. Okay, latent heat of vaporization of a water, which is equals to in the CGS system 540 calorie per gram. Ice melting point. Ice melts at 0 degrees centigrade. Suppose if you want to express that one in the Kelvin, that is 273 degrees Kelvin. This is we are taking as a lower fixed point while we are calibrating the thermometer, or while we are constructing. Freezing of water takes place at 0 degrees temperature, 0 degrees centigrade, and normal pressure. On freezing, volume of water increases. So regarding that one, just suppose if you take a glass bottle, and the bottle, suppose if you fill total water, if you put it that one in the deep refrigerator, after some time it will break. Why? Because well, while we are freezing the water, the volume of the water is increases. And dash are called as storehouses for the earth. Actually, oceans are called as storehouses for the earth. Why? Because whatever the energy, heat energy coming from the sun, that energy is absorbing these oceans, they are storing, and also they are equally sending throughout the area, surrounding areas. And rate of evaporation is a liquid, depends on it. So evaporation is depends upon the first one, surface area. If the surface area is more, automatically evaporation process is become very fast. And also amount of water and the temperature, on that is depends. So evaporation as an example is amount of water vapor and the temperature. For example, suppose if you take a glass of water, that may not evaporate fastly. Suppose if the same quantity of the water if you pour on your floor, it will very fastly evaporate. That's way evaporation is a surface phenomenon, and also that is the rate of evaporation is depends upon the surface area. Boiling point of water at 1 atmosphere, that equals to in terms of Kelvin, that is 373 degrees Kelvin. These are the main points you should be remember. సో ఈ వీడియో మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ ఫర్ వాచింగ్ మై వీడియోస్. థ్యాంక్ యూ.